So this is your Math 3 Unit 2 review for the test. So in number 1, we have a farmer is fencing in rectangular white regions in his field. Consider the field with width of 8x and a height of 2x measured in feet. Each fenced-in portion has a width of 10 feet as shown below in the picture. So part A, we wanted to find an expression for the width of the shaded region. So this kind of is a departure from what we normally do. We just skip right to B. But we want to find the width of this region without the white spots. Okay, now there are 4 white spots, 1, 2, 3, 4, that are 10 feet wide each piece, which means you are 40 feet wide. So the width is going to be 8x minus 40. Oops. There we go. So that's our width of our fenced-in area. Now to find a function a of x for the area of the shaded region, well, we take the height, which is 2x, times the width we just found, which is 8x minus 40. Okay, what is the maximum area of the shaded region can be if the total width of the shaded region is 200 feet? So we have 8x minus 40, oops, that's one too many zeros, equals 200. We're going to add 40 to both sides, which gives us 8x equals 240 divided by 8, x equals 30. So now we're going to put this into our problem. So we have 2 times 30 times 8 times 30 minus 40. Okay, so 2 times 30 is 60. 8 times 30 is 240, minus 40 is 200. We just saw that. So this seems like it's harder than it is. 6 times 2 is 12 with 3 zeros. Feet squared. All right, there we go. Next, we have same type of question. All right, Michelle is making a poster for the science fair. The posters come in different sizes and have side panels with a width of X inches. All right, the total width along the bottom of the poster is 36 inches. The height of the poster is 10x inches. All right, see the picture below. Michelle will only put pictures in the gray region, shaded region in the middle. Okay, so this one's a little bit more tricky, but it's the same idea. We have a total of 36. We're taking out 1 and 2 white spots that are x wide each. So they are 2x, because there's 2 of them. So our area is going to be the height, which is 10x, times 36 minus the 2x. Okay. All right, what's the maximum area of the shaded region if the width of the shaded region is 30 inches? Okay, so we're going to take 36 minus 2x equals 30. I'm going to subtract 36 from both sides. So you get negative 2x equals negative 6. Divide by negative 2 on both sides, and x will equal 3. I can then put that value back into my problem. So I have 10 times 3. And then 36 minus 2 times 3. So I will get 30 times 30. 3 times 3 is 9. And 2 zeros is 900. So we got inches squared. That sounds good. There we go. So that's it. Okay. Consider the function f of x equals x minus 2 times x plus 5. Dilate f of x by 2x to create a new function of a higher degree. So all we're doing is creating a new function. Our new function is called h of x. So we're going to put h of x is equal to, our dilation is by 2x. We're making it by x minus 2 and x plus 5. That's all you have to do. That's it. There's nothing else. You don't have to multiply because it doesn't say to put it in standard form, so just leave it like that. To identify the zeros, we have 2x equals 0. We have x minus 2 equals 0. We have x plus 5 equals 0. Solve those all for x. The first one you're going to divide by 2. X will equal 0. Second one you're going to add 2. X will equal 2. Last one you're going to subtract by 5. X will equal negative 5. Now this would be fine if it says write the coordinates. Then you should write the coordinates as x-intercepts. Because it doesn't say coordinates, that would be fine for me. If you do this, I'll be happy. Okay, analyze the graphs. F of x and g of x. Sketch the graph where you're multiplying the two graphs together. So this works like before. We've done this a number of times. We're going to put points where the graphs are crossing the x-axis, which is right there. Those are the only two spots your new graph can cross the x-axis. We're going to put some dashed lines. Oops. A little bit off. They go through the points that we have on our graph. You know what? Let's do this. I don't like those. Mainly because you can't see them. Let's make them red. Let's make them green. It's even better. Okay, so we have 1, 2, 3 spots to look at. Okay, in the first spot, first zone, the blue graph is positive, but the red graph is negative, which gives us a negative. In zone 2, the blue graph is positive, the red graph is positive. So 2 positive, which gives us a positive. And in zone 3, the blue graph is positive, and the red graph is positive, which gives us another positive. Because we have 2 positives in a row, what that means for our graph, so it's going to bounce. So it's going to start negative. It's going to go through the first point, to go back down to the next point, but then it's going to bounce up off the point. It's not going to go through and go down because it's in the positive zone, positive region. And that's it. That's all you got to do. Okay, again, we're going to make our points through where the graphs are currently going through the x-axis. We're going to make our dashed lines to make our regions. Okay, 1, 2, 3 regions. And the first one, the blue line is positive, the red line is negative. The second region, the blue line is positive, the red line is positive. In the third region, the red line is positive, the blue line is negative. So we're going to have a negative. Oops, sorry. Lefties. So in the first region, we're going to have a negative. Second one, we're going to have positive. Third one, we're going to have negative. It's going to look like this. The graph's going to start negative. Oh, let's go back to black. Start negative, go up through the point, be positive, and then go back through the point and be negative. So your graph will look like this. And that's it. That's all you got to do. Okay. So it says, consider the new function based on the expressions you're given. The new function is called m of x. It's going to be all those 3 functions multiplied together. But it says written in standard form. And because it says that, you have to multiply everything out. If it didn't say that, you could leave that as your answer, you'd be done. Okay, so remember, you can only multiply 2 things at a time. So you have x times x. Sorry, x times negative 4x gives you negative 4x squared. X times negative 1 is negative x. 2 times negative 4x is negative 8x. 2 times negative 1 is negative 2. I'm going to combine my like terms for those 2 things. Negative 4x squared minus 9x minus 2. I'm going to put the 2x plus 3 out in front because I find it's easier to multiply the 2 times the 3 versus the 3 times the 2. So again, I'm going to rainbow this sucker. 2x times negative 4x squared is going to be negative 8x to the third. 2x times negative 9 is negative 18x squared. And 2x times negative 2 is negative 4x. 3 times negative 4x squared is going to be negative 12x squared. 3 times negative 9x is going to be negative 27x. 3 times negative 2 is negative 6. So one thing we can't forget is that our function is called m of x. Now we can combine our like terms. We have negative 8x to the third. That gives us negative 30x squared. It gives us negative 31x and then minus 6. And that's it. You're done. Next, same idea. We have a new function from 2x minus 1, 3x plus 2, and negative x plus 3. We call it p of x. We have 2x minus 1, 3x plus 2, negative x plus 3. But again, oops, it says standard form, so we have to multiply all these things out. 2x times 3x is 6x squared. 2x times 2 is 4x. Negative 1 times 3x is negative 3x. Negative 1 times 2 is negative 2. Again, combining my like terms in the middle, I'm going to get positive x minus 2. Again, I'm going to bring the negative x plus 3 out in front because I find it easier to multiply the 2 times the 3 versus the 3 times the 2. So, negative x times 6x squared is negative 6x to the third. Negative x times x is negative x squared. Negative x times negative 2 is positive 2x. 3 times 6x squared is 18x squared. 3 times x is 3x. 3 times negative 2 is negative 6. Again, our function is p of x. So we have negative 6x to the third, positive 17x squared, positive 5x, and negative 6. All right, an example of a cubic function with 3 distinct roots. Okay, so a cubic function, first of all, it says a function, so we're going to write down f of x to write down that we have a function. Cubic function is x to the third. So there are 3 distinct roots. That means there has to be 3 x's in our 3 distinct roots. So we have x plus 1, x plus 2, and x plus 3. Here's 1, 2, 3 distinct roots. And because there's an x in each one, when we multiply those all, that's a really ugly x, but it's still an x. We're going to change those two. Because there's an x in all of them, it's x to the third when you multiply them together. And there you go. You're done. Number 9. All right. Again, we're dealing a cubic function, so we're going to write f of x. This time, you have one root, and it has a multiplicity of 3. So we can write down x plus 1 with a multiplicity of 3. There's your one root. This is your multiplicity of 3. You're done. Okay. Here we're using the fundamental theorem of algebra. Okay. So, again, remember the fundamental theorem of algebra says that a graph can have as many x-intercepts as the degree in equation. It can also have less. It can never have more. Okay. So on our first graph, we have 1, 2, 3, 4 different x-intercepts. In our equation, we have 1, 2, 3 x's, which will give us x to the third. Well, this degree is less than this number of x-intercepts, and that's not good. The x-intercepts has to be less than or equal to the degrees. This would be a no. The graph has more x-intercepts. Oops. There you go. Then the equation has degrees. Okay. Number 11, counting the x-intercepts of our graph, there's 1 and 2. Counting the x's in our equation, we have 1 and 2, that's x squared. So because the graph and the equation have the same number of x-intercepts and degrees, this would be a yes. The graph has the same number x-intercepts as the equation has degrees. And last but not least, again, counting the x-intercepts. 1, 2, 3, 4, 5. That graph goes through the x-axis 5 separate times. All right. Now, for this one, this is actually counted as 2 x's. So there's 2 here, there's 1 there, there's 1 there, for a grand total of x to the 4th. So this would be a no. The graph has more x-intercepts than the equation has degrees. There you go. All right, some review stuff. All right, so here, looking at concavity and x-intercepts. The concavity, since the 2 there is positive, we're going to be going up. X-intercepts, you're going to take these two numbers and change the sign and make them the x's. So we have 3, 0 and negative 4, 0. For this one, because this is a negative, we're going down. The vertex is based off of this number, this number and this number. You're going to change the h value, which is the h and k. So h becomes positive 3, the k stays at positive 9. Exosymmetry is based off of the x value of your vertex, so it's the h term. And the equation x equals 3. Lastly, the concavity is based on that number sign. Since it's positive, this is going to be going up. And the y-intercept is based on the last term. Oh, did it again. Sorry. The last term, which is right here. So we're going to have 0, 1. Okay, some evaluating functions. We're putting 4 into the p function. So we're going to have 2. Absolute value of negative 4 times 4 plus 3. So we're working the inside out. Negative 4 times 4 is negative 16. Negative 16 plus 3 is negative 13. But it's in the absolute value. When it comes out of the absolute value, it's positive 13 times 2, which gives you 26. The next one. M of 3 plus k of 2. So we're going to put 3 in for the m function. So we have negative 2 to the 3rd power minus 5 plus the k function is 1/2 times negative 3 times 2 plus 2 squared. So we're going to do the left side first. Negative 2 to the 3rd is negative 2 times negative 2 times negative 2, which gives you negative 8 minus 5. Negative 8 minus 5 is negative 13. All right, now we got the other side. From inside out, you go negative 3 times 2 is going to be negative 6. Negative 6 plus 2 is negative 4. Okay, so I have 1/2 times negative 4 squared. Now negative 4 squared is going to be positive 16, and 1/2 of 16 is 8. So we're still adding these things together, so negative 13 plus 8 is going to be negative 5. Next, k of 4, so I have 1/2 times negative 3 times 4 plus 2 squared. So again, I go work inside out. Negative 3 times 4 is negative 12. Negative 12 plus 2 is negative 10. Negative 10 squared is 100, and 1/2 of 100 is 50. All right, m of 0. So I have negative 2, 0 power, minus 5. Well, if you know the rules of exponents, anything raised to the 0 power is just 1. We have 1 minus 5, which gives you negative 4. Moving on, we have k of negative 2. What's k again? There we go. So k of negative 2 is going to be 1/2. Negative 3 times negative 2 plus 2 squared minus the p is 2 negative 4x plus 3. Went off a little bit of that one. Okay, that's a lot of stuff going on here. It's important again that you put the parentheses around this because you're subtracting. So inside out, starting on the left, negative 3 times negative 2 is positive 6, plus 2 is 8. So I have 8 squared times 1/2. 8 squared is 64. 1/2 of 64 is 32. Minus and minus. Okay, on the other side, negative 4 times 2 is negative 8. Negative 8 plus 3 is negative 5. Blanked out for a second there. So the absolute value of negative 5 is positive 5. And 2 times 5 is 10. So we have 32 minus 10 is 22. And lastly, we have this. So we have negative 2 squared, what's the back end of m, minus 5 times, we're going to put both of these in big parentheses just because we should. The p1 is 2, absolute value of negative 4 times negative 3 plus 3, absolute value with parentheses. Is that correct? Yes. All right. So here we go. Again, putting parentheses around our values that we're putting into our functions, putting parentheses around all of the functions this time because we are multiplying them, so it's important that we find the answers to those pieces first before we multiply them together. Negative 2 squared, because the negative 2 is in parentheses, is positive 4, and 4 minus 5 is negative 1. Times. Inside the other part of our function that we're doing, negative 4 times negative 3 is positive 12. 12 plus 3 is 15. So we have 2 times 15, absolute value of 15. Absolute value of 15 is just still positive 15, and 15 times 2 is 30. Negative 1 times 30 is negative 30. And there you go. All right. Solving. Oh, good. More quadratics. Okay. So in this case, you don't need to multiply 22 together. Please don't, in fact. It's already been factored for you. Just take each individual piece and set it equal to 0. X will equal negative 5 over 2. X will equal 3. X will equal 7. Please don't multiply those things together if you're supposed to solve them. Okay, for the next one, we did solving using square roots. So we're going to square root both sides. Those go away. You have x equals, oops. The square root of 16 is 4. Don't forget the plus or minus. If you wanted to, you could factor this as well. You would have x squared, and then minus 16 equals 0. So it would be x plus 4 and x minus 4. And you'd still solve it and get the same plus or minus 4. This piece right here is the part that everybody will forget when they square root both sides. So please don't do that. And number 24, we have to get this equal to 0 first. So we're going to have 2x squared minus 5x minus 3 equals 0. All right, and now we can see we can factor this. Remember, 2 times negative 3 is negative 6. Factors of negative 6 that equal negative 5 when you add them together being negative 6 and positive 1. Divide those both by the first term of 2. Negative 3 over 1 and 1/2. 2 bottoms up. I get x minus 3 is my first factor, and 2x plus 1 is my other one. Set those both equal to 0. X equals 3. X equals negative 1/2. Now, could you put that in the quadratic formula? Yes. But you do have to make sure that you do this part first, the minus 3. You have to move this 3 over to the other side before you can do anything, either factoring or quadratic formula. The same thing applies for this one. We have to move the x to the other side and put it in the right order. We have 2x squared. We're going to add x, and then minus 4 equals 0. I have a hunch that this is not going to work out if you factor it, because the factors would be negative 8, and no numbers of negative 8 multiply to give you negative 8 and add up to give you positive 1. This is a quadratic formula question. We have A, B, we have C. The B value is positive 1. So the formula is negative 1. It's the opposite of B, plus or minus the square root of 1 squared minus 4 times 2 times negative 4 all over 2 times 2. Okay. So we're going to have negative 1 plus or minus. Inside the parentheses, or inside the square root sign, you're going to have negative 4 times 2 times negative 4, which will give you positive 32, plus 1 is the square root of 33. Yes, all over 4. This is your answer for number 25. All right. Onward and upward, here we go. Again, this is going to be a quadratic formula question. It's going to be the opposite of B, which is positive 2 plus or minus square root of negative 2 squared minus 4 times 1 times negative 5, all divided by 2 times 1. There's your setup. 2 plus or minus the square root of. So negative 4 times 1 times negative 5 is positive 20. All right. Plus the negative 2 squared is going to be 4. So we're going to get positive 24 over 2. Here's a solving using square roots problem. To do this, we have to get the square root part by itself, which means we have to add 2 to both sides. So we're going to get x minus 5 squared equals 11. We can then square root both sides of the equation to get rid of the squared. X minus 5 is equal to plus or minus the square root of 11. And then add 5 to both sides. So x is equal to 5 plus or minus the square root of 11. And we're done. 2 more. In this case, there's no x term in this. And because of that, we're going to use solving using square roots. I'm going to add 8 to get 4x squared equals 28. Next, I have to get the x squared by itself, so I divide by 4. X squared equals 7. Now I can take the square root of both sides. The square root and the square root go away. We get plus or minus the square root of 7. Don't forget the plus or minus. And lastly, here. All right, again, in this case, we have to get the 1 to the other side. So we have 5x squared plus 7x minus 1 equals 0. I'm feeling this isn't factorable because negative 5 doesn't have 2 factors that can add up to be positive 7. So putting this in the quadratic formula, we're going to get the opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So we're going to have negative 7 plus or minus. Now inside the square root sign, we're going to have 49 plus 20, which gives you a square root of 69 over 14. And that can't be reduced, so that's good. And that is it. If you have questions, please ask before we get to the test. Good luck on the test.